This note is titled Sum and Difference of Rational Expressions. For the steps to add and subtract our rational expressions, we're going to factor those denominators and identify excluded values. Then we'll find a common denominator by creating the LCD, rewrite each rational as an equivalent expression by incorporating missing factors that are identified with the LCD. Then we'll simplify the numerators, add and subtract, and they're always going to write in simplest form, and sometimes that requires a last round of factoring. So just a reminder that sum means to add, and difference means to subtract, or rather what you get after you add or subtract. So our first few rounds are going to be adding and subtracting with common denominators. Remember, with fractions, in order to add or subtract, you have to have common denominators. So if the denominators already match, we could just skip some of those steps. So first, we are still going to factor our denominators, but because they're the same, we only have to do it once. And so if we have 6a squared plus 30a, I would first take out the GCF. This GCF would be a 6a, and then when I divide that out, I would have a remainder of a plus 5. So if I rewrite that denominator, it would look like this in factored form. So we're going to take each of those factors, set them equal to 0, and find our excluded values. So here a cannot equal 0 or -5. From there, we would have to factor and then create our LCDs, but since we already have that, what we can go ahead and do is we can actually go ahead and add and subtract since we have that common denominator already. So let's go ahead and keep that common denominator, and then we are going to, on this one, has an addition sign, add those numerators. If you want, sometimes it is helpful to just rewrite that top part with just the numerators, and you can write it Algebra 1 style, so you can see that all you're eventually going to do is just to combine your like terms. So 4a plus a would be a 5a, and -5 plus -1 would be a -6. And so now you have found the sum. And then the last step would be, can you simplify, factor, and divide out any common factors so we can always write our answers in simplest form? So since we've already factored that denominator, we're just going to take a look at our numerator and see what we can do about factoring. And so that is what we call the linear factor. Since our highest exponent is a 1, the only type of factoring that we can do is a GCF. And the only number in common between 5 and 6 is a 1. And so when I factor out a 1, it's going to stay the same. So that means there's nothing to actually simplify out and factor. That is going to be our final answer, 5a minus 6 over 6a and a plus 5. All right, again, we've got common denominators in that next one. So let's go ahead and do the steps again, where we would factor the denominators, but because they are already matching, we're only going to do it once. And let's go ahead and look for our GCF first. And we've got a 9x squared as a GCF. And then when I divide that out, we're going to get x plus 3. So we're going to take each of those, set them equal to 0 so we can find our excluded values. So here x cannot equal 0 or -3. All right, and then because we already have matching denominators, we can go ahead and keep that matching denominator, but I am going to write it in the factored form instead. And then let's go ahead and do our math up top. And now this is where we have to be careful with that subtraction. So just kind of rewriting it off to the side here. I'm going to take that first numerator and subtract my second numerator. And so remember, with subtraction, we need to make sure that we're going to distribute to both terms, and then we can combine our like terms. So 5x minus x would be a 4x, and then -4 minus 6 would be a -10. And then to finalize your answer, you always want to see if you can simplify and factor more. So we are able to factor that numerator. even though it is a power of 1, there is a GCF. That GCF would be a 2, and we would be left with the remainder of 2x minus 5. And then, of course, we would look for matching factors, or if we could reduce our monomials. But 2 is a prime number and 9 is not even, so I cannot reduce it. And so it looks like we are already in simplest form, and I'm going to leave it in that factored form for my final answer. All right, same idea on that next one. Again, we have matching denominators, so we only have to do the factoring once. And that is definitely a trinomial snowflake. So it looks like my GCF here would be a 1, so I'm going to jump into my snowflake there with my A times my C, my B at the bottom, my A next to my X on those top shelves left and right. I need two numbers that multiply to -6, but add to a 1. So that would be a +3 minus 2. And then, of course, we would reduce our fractions. Both of these can be reduced. My first one, I can divide both of those by 3. And I would get a 2x and a 1. So that would be my first factor. And then I can divide the second one by 2, and I would get a 3x minus 1 for my second factor. And then I would take each of those, set them equal to 0. And when I solve for x, I would have two excluded values, -1 over 2 and 1 over 3. All right, from there, because we have matching denominators, I'm going to keep that denominator. I'm just going to write it in the factored form. And then we're going to focus on our subtraction. And then remember, we're going to be extra cautious with that part. So if you don't want to rewrite, you don't have to. Just remind yourself that you do have to distribute that negative to both terms, or however many terms are on that second fraction. And so this would be a -2x minus 1 with a plus 8x minus 1 now. And so when we combine our x's together, -2x plus 8x is 6x, and -1 plus a -1 is a -2. And then from there, let's see if we can factor that numerator, and there is a GCF. And so we can see that we actually can simplify this further. We do have a matching factor from the numerator with the denominator. So as we had done in the previous notes, we can divide those out. And so we are going to be left with a 2 over 2x plus 1. All right, so not too bad when you have the common denominator already. On the back side, we're going to have 2 where we do not have a common denominator. And so when we do our steps and we factor, we are going to have to make sure that we factor both of the denominators and then create our LCD. So we'll just do one step at a time, starting with our first denominator there. First thing I would look for is my GCF. So I do have a GCF of an x, and when I divide that out, I get x minus 5. So I'm going to put those here in my list of factors that are going to become my excluded values. Okay, on my second denominator, I've got a trinomial there. Looks like I have a GCF of 1, so I'm going to jump straight into my snowflake and do my A times my C, my B on the bottom, my AX on my top shelf, left and right. Two numbers that multiply to -10 that add to -3. That would be -5, +2. And because those are ones, my fractions cannot get any smaller. So we're going to have x minus 5 and an x plus 2. And then you can see we have a repeat. You can write it if you want, but we know that both of those are going to end up giving us the same x value. And so when we write our final excluded values, starting with our first one, 0, and then I would get 5 for this one and 5 for that one, but we only have to write it one time. and then the -2 from that last one. So we have only 3 excluded values. All right, our steps say before we can add or subtract fractions, we have to have a common denominator. So that's what we need to do next. Right now, we can see that we do have a piece that is in common, but there are parts that are not. And so just like we had done on the notes with creating the LCD, whatever the first fraction has, we need to multiply it into the second fraction if it is missing. So my first fraction here has a monomial x, so let's go ahead and multiply that in, and then remember to keep your balance. Okay, and then now my second fraction has one extra factor with that x plus 2, so we're going to multiply that in to both the numerator and the denominator. Pretty much from this point, all of your work is going to be from up top, only from those numerators. Your denominators now match, so what you could do is you can go ahead and write out your factors so that you don't get lost in your work. And then we're just going to focus on the math from up top. So I'm going to rewrite my numerators to look more algebra style, and then just focus on doing those basic polynomial operations. So we would distribute first, and we would follow our PEMDAS, and that negative x squared times x would become a negative x cubed. And then we would look to see if we have any like terms that we could combine, and we've got some x cubes there. So 2x cubed minus x cubed would just be x cubed, and then I would have that plus 4x squared behind. Now you have actually combined these fractions into one by subtracting, and so your final steps would be, can you simplify that further? So up top, I would definitely take out my GCF. My GCF there is going to be an x squared. So when I take out and factor out that x squared, I would have a remainder of x plus 4. And my denominator is already good to go. We're basically just going to keep bringing that around until we're ready to use it. So at this point, it is ready to be used. We can simplify. I don't have any common binomials, but we do have some monomials here that we can reduce using those laws of exponents that we have practiced in our notes with the simplifying rationals. So that x squared over x is just going to become an x. If you need to write it out expanded, where x squared becomes x times x, and then you can divide out those x's, that might be helpful to you. But your simplified expression is going to be x with an x plus 4 in the numerator, and x minus 5 with an x plus 2 from the denominator. Okay, last one. Again, we do not have common denominators. First thing is going to be to factor. So x squared is a monomial, so not much I can factor there. I will go ahead and put that here as one of the ways that we're going to get an excluded value. Okay, I can factor that second denominator, starting with a GCF, so it looks like a GCF of x, and then I would have a remainder of x plus 1. So I would put those in. So now I have all the factors of my, let me write that a little bit nicer. I have all the factors of my denominators. And so when I solve that first one, I would get a 0. The second one is also 0, so I don't have to write it again. And then our third factor would end up giving us a -1. So only 2 excluded values from there. Next up, we would look for commonalities so we can create a common denominator. So I'm actually going to rewrite this just a little bit here off to the side, but I'm only going to look at those denominators so we don't get lost with up top. So I know I have an x and an x plus 1. My first fraction has a denominator of an x squared. I can rewrite that as x times x to look like it's in factored form. This is going to help us see that there is something in common, and we don't have to create a giant LCD because we already have the monomial part that's matching. There's only one factor from each one that needs to be multiplied in. So I do have a second monomial x that I'll need to multiply in. And then I have that binomial x plus 1 that I'll need to multiply in. So sometimes it's just helpful to rewrite it off to the side, and then focus on your math with your numerators. So what that means is I'm going to multiply in an x plus 1 to my first numerator, and then I'm going to multiply in an x to my second numerator. And I'm just going to focus on rewriting that top part. This way, it doesn't look so intimidating in fraction form. And really what it is just a giant, long Algebra 1 problem. So we've got some multiplications here. So again, we're going to follow our PEMDAS. So inside of parentheses, everything is simplified. So for example, with this first one, I can't combine anything in that trinomial. There's no like terms. Same for my x plus 1 and same for my x. Exponent-wise, I don't have anything outside of parentheses, so I don't need to rewrite things multiple times. So next up is going to be to multiply. So we're going to start distributing here with that x squared. And you don't have to draw your arrows if you do not want to. I'm doing it just so for notes purposes, you can see which terms I'm actually multiplying. And then I'm also going to distribute in that last part. So x squared times x would be an x cubed. All right, from there, let's just combine our like terms. So I have some x cubes that can go together. So that'd be 2x cubed. I also have some x squareds. Those would combine. And then I have some just basic x's with an exponent of 1. And then my last constant hiding in the back. So this would be our new numerator. Now this is going to go over what we have placed as our LCD, which was x, x, and x plus 1. So the only thing that we need to do to finish this out, we've combined these two fractions into one. The last thing is, can you simplify it? And so let's look at that numerator and let's see if we can factor that. And this way we can look for any matching factors. So for terms, let's go ahead and do or attempt to do a grouping. GCF wise, it looks like we have just a GCF of a 1. So I'm going to jump straight into the grouping there. And then my GCF of side 1 would be x squared with a remainder of 2x plus 5. My second side has a GCF of 2 with a remainder of 3x plus 1. So those are not matching. That means it cannot be factored by grouping. And so for us, that means we are done. It cannot be simplified any further. And then you can leave it as x times x plus 1. You could also see it where they put those monomials together and leave it as x squared times x plus 1. Both answers would be in correct form.